Welcome back to another Khan Academy tutorial. Today we're going to be doing the Simplify Square Root Expressions exercise. So for this one, we kind of need an understanding of how to simplify radicals, how to look for perfect squares, understanding how to do the factor tree. So if you need additional help, I have some other videos on that. This one's a little bit more advanced because we have some combination with variables, okay? So let's go ahead and break this down. We have a square root of z here. We have a 30z squared, and we have a 35z cubed. And all of these are underneath the radical, okay? Be very careful as you write radicals. You don't want to have some hanging out like that because it's vague whether or not this z squared is inside or outside the radical. So if you have a number that belongs outside the radical, make sure to write that in front of the radical. That is the best way to do it to remove any confusion, okay? So I think you'll make your math teacher very proud and very happy if you do that, and of course you'll do better on your tests and quizzes, okay? So now let's go ahead and try to break down each one. So this first one, there's nothing you can do with the square root of z. There's no perfect squares within it. There's no exponents. So we're going to go ahead and leave square root of z by himself for now. The next one. So what we'll do here is there's no way to simplify the 30. There's no way to simplify 35. How do I know? Well, if I'm factoring square root of 30, I divide it by a prime number, 5. I'm left with 6, 2, 3. I have no doubles of any number, okay? The 5's by himself, the 2's by himself, the 3 is by himself, okay? So there's no way, there's no perfect squares, and we're talking about perfect squares, we're talking 4, 9, 16, and 25. Those are some basic square factors, meaning we can take the square root of all those numbers, and none of them fit into 30, okay? So that's a problem, and then we also see that the square root of 35 does not have any perfect square factors. If I divide by 5, I get 7, and that's it. Those are prime numbers. There's no doubles. There's no other factors that are perfect squares. So we're going to leave the square root of 30 by himself for now also. And we're going to leave the square root of 35 by himself in addition to the other ones. So go ahead and write those. Now, the ones that we can handle are the square root of z squared times, and then and the square root of z cubed. Okay, so how do we factor those ones? Well, let's take a look at z squared first up in the top right. If we have a square root with a square inside, it's essentially undoing the square root, okay, and undoing the square. So this becomes z. What's another way to think of that? Well, the square root means what times itself equals the thing inside. So the thing inside is z squared. What times itself twice gives you z squared, and that, of course, is z. So this is going to be equal to z. No radical, okay? Also keep in mind that if it's a square root, technically there's a 2 in the corner, but it's just implied, okay? So you don't need to write the 2 for square root, but know that's implied, so what times itself twice gives you the thing inside the radical, okay? Now z cubed is a little bit more tricky, but it's not terrible. So if we have z cubed, we can split this into factors. We're looking for perfect square factors that fit into z cubed. And that, of course, is z squared, the square root of z squared, and the square root of z. The reason why I picked z squared is because I can take the square root of that, and I get z. And then, of course, we're left with square root of z by itself. Okay? So here we have, this one becomes times z times square root of z. So if I put it all together, I only have 2 things that can come outside of the radical for now, and that is the 2 z's, z times z. So I'm going to get z squared when I do that. Now what I'm going to do is I'm going to multiply everything underneath the radical. What happens when I do that? Well, I do z times z here in purple, these 2 z's underneath the radical, and I'm going to get z squared. Then I have 30 and 35. So let me get a little calculator for that. But it should be it's not going to be too complicated. We just do 30 times 35, and that gives us 1,050. Now here's the thing. If you wanted to, you could go about finding the perfect square factors of 1050. Okay, that's one way to do it. Or you could do it an easier way, and that is to write the prime factors of 30 and 35. And we already did that over here. So it was kind of a good thing that we've already done that. So what we're going to do is we're going to write 5 times 2 times 3 times 5 times 7. Why did I do that? Well, now I'm going to look for any time I see two factors, the same factor. And here I see a 5 and a 5. The 2 doesn't have any pairs, the 3 doesn't have any pairs, and the 7 doesn't have any pairs. The z squared has a pair, okay, because we already established that the square root of z squared is just z. So what I'm going to do is I'm going to factor out this z squared, and I'm put it into the front, and it's going to become z. So I have z squared times my buddy z. Now, what happens with these 5s? Since I have two 5s, I could rewrite it as the square root of 25. Well, we know the square root of 25 is 5. So anytime we see identical factors like this, we can factor out one of them. So if there's 2 inside the house, inside the radical, 1 can come out. I like to say you have to have a date in order to leave the house. So the 5's got a date. He can leave the house. But guess what? The 2 doesn't have a date. The 3 doesn't have a date. The 7 doesn't have a date. So all those factors need to stay inside. Now we can combine like terms outside. Z squared times z gives me z cubed, but I have a 5 in front, 5z cubed. And this times the square root of 2 times 3 is 6, times 7 is 42. And this becomes my final answer. Really long, involved problem here, but definitely teaches you a lot of different concepts all at once. So let's go ahead and 5z cubed, square root of 42, 5z cubed times the square root of 42. Check that answer. Good to go. And we got a quick one to end on. Perfect. So first thing we're going to do, we're going to split this up into 3. You're going to see most of your problems are going to be like this, not that big doozy of a problem we just had. And I like to split it up into 3 segments first. Okay, so let's start with our number. This is going to be the most complicated. I know the factors are 2 and 36. And if I continue factoring, I see it's 2, 18, 2, 9, 3, 3. So what I do is I always look for pairs with square roots, 2 and 2, 3 and 3. 2 stays home. 1, 2 is going to leave the house. We're going to multiply it by 1, 3 that leaves the house, and the 2 is going to stay inside. So this becomes 2 times 3, these 2, times the square root of 2. And that's my simplified form of square root of 72. Let me write that up here in the middle. Actually, I kind of like it at the bottom. We'll leave it at the bottom. Now, we already talked about this before, but we can split x cubed into the square root of x squared times the square root of x. Well, we know x squared gets reduced to x. So then we have x radical x, and we're going to put that down here. Finally, it's basically the same thing with z. We can factor it as z cubed and square root of z. Oh, sorry, that's not z cubed. It's z squared. Z squared times z gives me z cubed. And that becomes, let's use orange, z square root of z, z square root of z. So our final answer becomes 2 times 3 is 6 times x times z times the square root of 2xz. So 6xz times square root of 2xz. Let's go back. 6xz times radical 2xz. There you go. I hope... Sorry, I got interrupted. I hope you enjoyed this video, and I hope you found it helpful, and I'll see you next time.